Welcome everyone to another episode in CPD in 43. It's our August event, which comes to you from Will Arnold of iStructE. It's Reducing Embodied Carbon with a Structural Engineer. Will is a fellow of the Institute and head of climate action, along with being an active contributor to a number of cross-industry initiatives. So well placed in regards to sort of having this discussion and giving us a really interesting talk on structures. So without further ado, I will hand it over to Will. Naturally, I'll be in the background. Please do ask any questions in the chat box, which will be fielded at the end of the talk. Thank you very much, Will, and I'll hand it straight over to you.
Thank you, and thank you everyone for giving up a chunk of your day to listen to me speak today. So it's nice to see so many of you, given that probably so many of you have got nice weather outside and you could be sat out there bathing in the sun instead of listening to me talk about embodied carbon. So I'm honoured that you've chosen me over the weather. Thank you. Hopefully you can see my screen okay, and I'm just going to start unless anyone says otherwise. So yeah, as mentioned, my name is Will. I work for the Institution of Structural Engineers. I was a practicing structural engineer for a little bit over 10 years before I moved to the iStructE. And my role here at the institution is to effectively help the structural engineering profession to try and decarbonise their work, to take responsibility for the emissions and the environmental damage that's done through our use of construction materials, and then to act on that responsibility to change the way we do things. So I'm going to talk to you today, I guess, about the sorts of things you could demand from the structural engineers you work with. Maybe you are listening as a structural engineer, in which case I'm going to be talking to you about some of the things that we as the institution are enabling you to do going forwards. And I'm also going to talk you through some of the work the institution has been involved with that will enable you, whether you're listening as an architect, technician, an engineer, something else, some of the resources we've created over the last few years that we've made available to people such as yourselves to help you sort of put some of this stuff into practice. So I often start talks like this with this kind of question: why bother? Why are we talking about all this? And I'm conscious of the fact that you probably don't need telling the answers to this, because you probably wouldn't be giving up your sunny lunch break to listen to me if it wasn't for the case that you understand fully what the problem is. However, I think we all need a bit of a sort of top up of ammunition from time to time on this topic. So I've just got a couple of quick slides on the needs to act in this space, and hopefully it'll give you some sort of tidbits that you can use when trying to persuade other people to listen to you making the case on climate as well. The first, of course, is that we now live in a world of 1.5 degrees warming, and what's happened to our climate is pretty bad. Actually, we're only at 1.5 degrees, and yet we see month in, month out, worst ever type events happening around the world. This slide's slightly out of date. These are all from 2024, but each of these events happen in those months shown, and these are photos from those actual events. This included forest fires within the Arctic Circle and flooding in the desert. So this would have been considered pretty weird a couple of decades ago, and yet we're somehow growing used to it. This has become so normal that in California, they don't have fire season anymore for their forest fires. It's just year round. It's totally unprecedented, and it's only going in one direction, worst of all. So it's only going to get worse. Current policies and actions around the world put our planet on course to hit something between 2.5 to 3 degrees of warming by the end of this century. The end of this century often sounds quite far, but if somebody was born today, they'd be 75 at the end of this century. So that's not that old. That's not that far away. They were almost certainly going to live through to that age. It might be worth thinking about how old, I don't know, you or maybe your kids are going to be by the time we pass 2050 and get towards 2100. I don't think I'll be around anymore, but I'm pretty sure that my nephews and nieces still will be. They're going to be in their 80s. So this is real stuff that's happening to real people today. And those photos on the previous slide is just a taster of what's to come. This is only going to go in one direction. That's the sort of moral imperative. But at the same time, we've got a bit more a sort of a financial and a legal imperative on this as well. And this is going to get stronger as a result of what's happening to climate. We've had senior people from banks such as Allianz speaking out recently to say that actually at about 3 degrees C, the property industry may well become totally uninsurable. The insurance market, when it comes to property insurance, works on the basis of them hedging their bets against all of our properties. You pay them a bit of money each year, enough people do that, they build up their dividends, and every now and then they'll pay out in response to something like flood damage. But what they're saying is that at 3 degrees C, those weather impacted or sort of weather related impacts are going to become so frequent and so severe that they wouldn't be able to make any money out of this as an industry. And at that point, property insurance ceases to exist. At that point, mortgages disappear. This entire industry has this existential threat that we're looking at if we don't get climate change under control. That was a quote from a senior figure at Allianz. It's interesting to note that if you look back about 10 years or so, the chief exec of AXA around that time said almost the same thing. He was saying it at about 4 degrees was his guess for that point in time. Allianz are now saying 3. It'd be interesting to see where that figure has been put in 10 years' time from now. But this is a significant, a serious, and a real world thing. That's not to mention what's happening from a commercial point of view on projects today, right? So, we've got more operational disruptions on site than ever before as a result of worsening climate change. We've got flooding and droughts and high winds, and all of these things cause delay and damage. Winds stop work at heights. Heat waves can stop work altogether. It can stop concrete pouring. The water table moving up and down will affect excavations and ground movements. Storms affect what we can do with timber. All of these things are real things, and they have cost implications on our projects today. And again, this is a reason why we need to act. And just in case the commercial bit and the moral bit wasn't enough, and you feel you need something more to argue with your clients or your collaborators with, this is moving into legislation now. This is only going to go in one direction from a legislative point of view. So in the UK, already about 1/5 of all local authorities require some form of embodied carbon assessment to take place as part of the planning requirements. That number's growing all the time. These images on the screen are from a paper that you can find in the bottom left-hand corner. And this number keeps growing. What's interesting in the UK is we don't have a sort of national policy yet on this, but it will come. That is also inevitable. This is what we see overseas in the EU. The EU have mandated that from 2028, embodied carbon submissions will be required for all major projects. And from 2030, that will be extended to projects of all sizes, and will also then include legal limits on the amount of embodied carbon you can emit during construction. We've seen countries doing this for a while now. Nordic countries for several years, France for 2 or 3, the Netherlands, I think for about 10 or 12 years, they've had this sort of approach in place. And we even see this happening in states of the USA. So California, Colorado, New York, Oregon, they're the big 4 that always stick in my mind. They all require embodied carbon reporting. And this is in the USA with all of the stuff that's going on around climate and legislation at a federal level. Those states are holding strong. And that might just sound like 4 states. That might not sound very big, but actually if you add those 4 together, their combined GDP would put them 3rd if they were a country that was being ranked in terms of a size of economy. So it'd be the 3rd largest economy in the world would be those 3 states. So that's a pretty significant proportion of construction being covered by this. The UK will follow suit. It's inevitable. It's just a matter of time before it happens. So that's kind of the contextual bit. I suppose that's the bit that tells us, the need to start caring about this. We now need to move on to what we can do about it. If you're not aware of who the iStructE are, we've been around for just over 100 years. We're the world's largest membership organisation that's dedicated to structural engineering as a profession. We've got about 30,000 members, and about 2/3 of those members are in the UK, and the other 10,000 are spread around the world. You can see on the screen we cover nearly 140 countries. What's important, and the reason why I put this slide in when I speak to external groups, is that we have a royal charter that means that we have to exist for the public benefit. The reason for an institution like ours to exist is to help protect the public when it comes to their buildings. We were set up in response to the rising use of reinforced concrete back in, well, like you see, 1908, so the turn of the 20th century. And about 5 years or so ago, our board and our council made a commitment that from now on we would treat sustainability the same as safety, because they are, in effect, one and the same thing. This has led to all sorts of changes in the way that we do things. So if you want to become a chartered structural engineer now, as part of that, you'll be tested on whether or not you can communicate and reduce embodied carbon, whether you understand sustainability in broad terms, your experience of reuse of existing buildings, what can you do with materials. These are now requirements to become a chartered structural engineer. So if you're working with one of those structural engineers, you can sort of have that requirement as well. Now, you should be able to speak about this stuff fluently with those engineers who you work with. That is a sort of entry level thing for existing members who are required to complete CPD returns every year. We now mandate that they tell us what sustainability CPD they've done as part of that. We sort of pull that out as a separate thing. So we're pushing this at all grades. And at the top end of what we do as an institution, when we have our yearly awards, we refocused all of this a few years ago as well. It is now impossible to win a structural award without understanding the impact that your project has had on the planet. We've refocused our awards around the outcomes that result from our projects. And if the outcome is that you've emitted bucket loads of carbon, way more emissions than would be normal for the sorts of buildings you're working with, then the judges need to be convinced as to why that was worth it. What was that ecological investment giving to society? What was the sort of return on investments, if you like? And as a result, what's been really interesting is we still get, some big, bold projects being entered into the awards, and some of them still win awards because there's very good reasons why people have done the things that they have. But what's been really interesting is we've also seen this whole new sort of broadening within the awards, looking at a much more sort of international set of projects as well. Final thing to note is that we've got different grades of membership. And within that, if you are, so I'm about to start taking you through some of the sort of free guidance we give away, but there's obviously quite a lot of paid guidance out there as well. And if you're interested in any of that, I'll just draw your attention to the bottom of this slide where it says affiliate scheme. You don't have to sit any entry requirements or anything to become an affiliate. There's a small membership fee per year, but that gives you membership level access to a lot of the stuff that we create, which can give you big discounts on other stuff. Basically, a way to get some of our guidance for cheaper. Let's take a quick swig of water. So that takes me on to the guidance that we've produced. And the first thing I always point people to on this topic is our sustainability resource map. If you go on Google and you just search for sustainability resource map iStructE, words to that effect, or on any other search platform for that matter, this should come up. This is basically just a PDF document. And it's laid out, you can sort of see on the screen, it's laid out a bit like a spider diagram. And, there used to be a sort of zoomed in bit for that one. So if I click on this, there we go. And if you were to zoom into one corner of it, you can see the sorts of things that are in there. Now, each of these resources are links. They're live hyperlinks. We check this and update it on a yearly basis, so they should mostly still work, I would hope. And we've grouped them into essential resources, further reading, videos, external content, stuff like that. There's about 400 items on this PDF, so there's a lot of stuff in there. But we're hoping the way we've arranged it helps you navigate your way around it. And of course, you can use the search function on Adobe PDF or whatever you use to find what you're looking for, and then you can click through. And yeah, if you were to click on that blog, it takes you straight to that website. It's worth saying, probably my guess would be that a quarter or so of the resources on this PDF are free for anyone who wants them. And then obviously quite a lot of it is iStructE members only, just so you're aware. But often a lot of the essential resources are the free stuff because it's a bit more high level. It's sort of thought leadership pieces. And these are some examples of what some of that guidance looks like. So, an article on embodied carbon in structural concrete, where it comes from, how you reduce it, some pieces on design in concrete. I mean, these happen to be a bunch of cement and concrete examples because this is a slide deck. A slide from a deck that I used with the concrete industry quite recently. But you can see the sorts of the ways we present all this information. There's then some other sort of like big hitting pieces within that. So the first one I'd draw your attention to is this pair. On the right hand side, you've got the how to calculate embodied carbon guide. It's downloadable as a PDF, free for anybody who wants it. You have to make a login, but that's just so we know you've got it, so that when we create the 4th edition, you get an automated email telling you, please download the new one, that sort of thing. And what goes alongside this guide is the tool that's on the left. The tool is just an Excel spreadsheet, but it basically automates everything that's in the guide for you to save you some time of having to do it yourself. These are probably 2 of our most popular downloads from our members. We know that something like 2/3 of our members now carry out embodied carbon calculations with most of their work. And we know that from them, about 2/3 of them use our tool to do this. So it's proved pretty popular. I think it hits a really nice sweet spot where it's fairly simple to use if it's the first time you're doing something like this, but you can also customize it quite easily if you want to do more with it. So we know people who have taken that tool, they've embedded it into workflows, they've paired it up with things like Rhino and Grasshopper scripts, stuff like that. And we make the tool available open access, so you can unlock it. It gives you the password on the information page, but I'm pretty sure it's just carbon. You can unlock it and then you can change things. So if you wanted to add different types of materials or change the functionality of it, that's fine. You do what you want. And we know people have translated it into other languages, made it applicable to other locations, that kind of thing as well. The 2 other sort of guides I wanted to draw people's attentions to, one was on the circular economy side, which is the guide on the left, and the other's on regenerative design, which is the one on the right. And just a quick sort of minute on the 2 of those. The circular economy guide is super practical. So this is not about just the principles of circular economy, but it's answering the question of how do I actually take, say, bricks from a project that we're about to demolish and reuse those bricks on my project today. I think the guy's about 2 years old now, and this is a very fast-moving area. So obviously there are some things in it which even in the last 2 years have come on leaps and bounds. We see a lot more steel being reused today than we did 2 years ago. But it gives you some really sort of practical advice on this stuff. Our online training courses, the main one that I always tell people about is called Embodied Carbon Basics. Now this is free for members, but I don't think it's free for members, but I don't think it's free for anyone else who wants it. So if you were an affiliate member, you could get hold of it for free. Or you can, I mean, there's a small fee if you want to pay to do this in your lunch breaks. It's about 5-6 hours worth of online CPD. It teaches you how to calculate embodied carbon, tells you what to do with those results, goes into the nuances of different materials. It's pretty good, it's pretty in-depth, and all that's presented by experts on these topics. So Jenny Burridge, who's on the screen in front of you, she works at the Concrete Centre. She's an expert in embodied carbon and concrete specifically. So she gives us that bit, the steel equivalents done by her counterpart from the steel industry and so on. And then we've got some things like webinars. Our Climate Emergency Conference ran about a month ago. I think we had about 400 attendees, which was really nice to see. All of that was recorded. That should be online soon. I was hoping that by now I'd have a QR code to give to you so you could download them all, but it's not quite ready yet. It'll probably be another week or so. But if you check in with the website, you'll see it when it goes live. And then we've got some formalized training courses. So I mentioned Embodied Carbon Basics already. But the Net Zero Structural Design course on the right, as an example, this is taught CPD around this topic. So this is like a 5-week course. You get trained by myself and an expert in conceptual design, and we talk you through various stages of design and what you can do about it to decrease the carbon footprint of your project, that kind of thing. And then the very final resource I wanted to touch on is called our Concrete Technology Tracker. This is a lot of people have told us this is one of the most useful things we've got out there, and it's basically because if you were to go on to the internet and search low carbon concrete, you could be forgiven for assuming that there's like 1,000 different concrete technologies and they're all ready to go. You can buy them today. They're the lowest carbon thing ever. You just got to go and place your order, and that's just not true. There's not 1,000. We think there's probably about 15 different technologies being developed at the moment. And so what we've done is we've taken all these different products and we've grouped them together in these technology streams that you see on the slide that's in front of you. And then for each of those technology streams, we've done a bit of an assessment as to potential carbon savings, the sort of technological readiness. So could you buy it today, or is it something that's being piloted and maybe they're looking for opportunities to do very small pours with it? Is it maybe still stuck in the lab? Going to be a little while longer. And then under each of them, we give a few sort of questions that you might ask if you were to get in touch with these with these companies. And of course, we've got links to those companies that we've spoken with about those technologies as well. So it's a bit of a sort of wayfinding map into the world of concrete decarbonisation, which I think was quite sorely needed, given the sort of opaqueness of all of that up until now. Final bit then. I wanted to just talk at the very end about cross-industry collaboration, and I think it's quite fitting because obviously, I work for one institution. I'm speaking to you today because of the CIAT, another institution, and the work that they're doing to share CPD in this space. And this sort of cross-industry collaboration that I've seen on climate in the last 5 years in particular is really impressive, and it's like nothing I've seen on any other topic when it comes to the built environment. This gives you a bit of an understanding of the various sort of things going on around the UK construction industry when it comes to carbon alone, and that's before you get into any other form of environmental impact. And all of these different groups they're pretty good at talking to each other, in my experience. So a lot of the steering groups and the things on the screen contain a lot of the same people. I think I personally have probably been involved with about, I'd say 7 maybe of these things on the screen in front of you today, and there might be another 7 still where I know people well enough who have done those things, so I could put you in touch. We're doing our best to try and stay joined up, and I think that it's something we should be quite proud of as an industry. Actually, we're not yet being directed to do any of this stuff by government, not in the sense of at a project level, and yet we're seeing the industry move on it anyway because people know that it's the right thing they do. They want to have a feeling that we're creating something as an industry, or they've created something with their work that we can all be proud of. And so we've seen some real change happen in the past 5 or 10 years, and change that I think I'm only seeing sort of continue further and further forwards. I wanted to just touch on a couple of key things from this. So the UK Net Zero Carbon Building Standard, Part Z, and then a couple of sort of thought leadership pieces that are out there before I wrap up. Hopefully you're all aware of the standard, as we call it. If you're not, again, you can just Google it, download a copy and have a look at it. Quite daunting the first time people look at it is the feedback we've had, but actually we've got about 200 projects worth of people pilot testing the standard at the moment, and the feedback we've had from them was once they got their teeth into it, actually it makes a lot of sense. They can find their way around it quite easily, and they know what they're doing. Generally, the feedback's been very, very positive in terms of its usability. It's just the first time you look at anything new, particularly a standard, it sort of takes you back a little bit. But this slide gives you a bit of an overview of what's in it. This is a rule book for what a building must do in terms of the way it performs if we want to refer to that building as being net zero carbon aligned, i.e. aligned with the UK's net zero laws. So this standard contains a whole load of requirements for reporting on these different metrics that you can see on the right-hand side of the screen: upfront carbon, operational energy, and so on. For some of those, it sets limits, and those limits are based on a 1.5 degree carbon and energy budget for the UK, what's left of it. Some of the other metrics we don't set limits on, they're reporting only. That's really so we can build up data as an industry, maybe with the view of one day we would introduce limits for those things if we got the right data in place. And then you can see at the bottom that this applies to new buildings, existing buildings, and ones that are a mixture of the two. It also applies to lots of different building typologies, so we call them sectors in the standard. Covers everything from housing and commercial right through to things like science and tech, arts and culture, logistics, distribution. It's all laid out at the start of the standard, and you can use the standard to approach a multi-use building. So if you've got retail on the ground floor and then 5 stories of flats above it, we tell you what to do with that as well, and we give you a limit for those various limits. That's a sort of prorated thing of the different uses. It's sort of fair. I've only got this second and only other slide on the standard is just to give you a bit of an insight as to what the sorts of numbers are inside it, because that's usually the first thing people ask. Is what are the carbon limits? What are the carbon targets? And so the top line, the dark blue line, is for offices. The bottom one in pink is for flats. There's other lines again for single family homes and sci-tech and healthcare, things like that. And these are just the upfront carbon limits. This is modules A1 to A5. We don't set limits for future embodied carbon. And there's another set of graphs and numbers for things like operational energy. What's important to understand with this is you can see how those numbers go down in time. They basically, we ask you to work out when you're going to start on site. And that date of commencement is the date that you lock in the limit that you're trying to meet. So if you've got a project that's going to start on site in 2027 and it's a block of flats, you get a limit of just under 500 kilos carbon per square meter. That's what you've got to meet with what you build. And the standard is based on as built in use data. So we ask you to record actual measurements of material quantities, actual EPDs that you've used, and so on. And these limits get tighter over time, partly because we expect people to get a bit better at reusing things and using things more efficiently. But actually, quite a lot of this curve just comes from the decarbonisation of materials themselves. So the materials industry's all got their trajectories towards net zero that they're now going along, and we've reflected that with a little bit of cynicism when we did it, but we reflected that within the limits that you have to meet. So the idea is that a building being built in 2030 and a building built in 25, yes, one of them's got a lower embodied carbon limit than the other, lower upfront carbon limit than the other, but they're both equally as ambitious, is the idea, because we're reflecting the changes in technology and so on that we believe are coming. Part Z's the second of the sort of two big cross-industry things to mention. If you're not aware of Part Z, please look it up. This is a cross-industry proposal to regulate embodied carbon. So this is effectively, if we go back to one of those very first slides I showed you where I told you about how different local authorities are doing things in this space, Part Z is a call from industry to government to say, please, can you just make this a centralised, regulated thing, bring consistency to the industry, bring a level playing field to everybody who's working in this space. That would build on top of whatever local authorities are doing. Planning could then follow regulation. It would mirror what the EU is doing on this topic. So we've now, our industry would be competitive with theirs when it comes to the sort of demand drivers on decarbonisation of materials and so on. Government's been doing research on this recently. They published a report on it. Happy to answer more questions on that if you've got them. I'd say that this is sort of like slowly ticking along. I think it's inevitable that this will happen at some point. Probably won't be quite on the dates that are on the screen in front of you, which is our proposal of 2026. So this coming into force. I think we said 1st of January. But it will happen at some point, because if it doesn't, then we're going to be sat there as an island surrounded by countries who are doing all of this. And that would make no sense. If you've not seen this before, and have a look at it, if you think it's something that you are in support of, do have a look at the list of supporters that are on there. And if your company is not listed, please do use the add your support button to give us more signatures. We've currently got about 250 signatures on there. We'd like to get that number as high as we can. We know that when we speak to governments, it helps if we can say the whole industry is behind something. And very last two slides, and then I'm going to hand over to Q&A because we're just approaching past. Is basically to just talk about two thought leadership papers that we've helped produce cross-industry in the last couple of years. One is on the use of GDBS as a replacement for cement, and then the second is on the role of scrap in the production of steel. The two reports, they follow a similar sort of path. They basically both talk to us about the problem with hoarding a low carbon material at the expense of everybody else in the industry who can no longer use that material, one that's got a sort of finite limit to how much can be used each year. And it calls out what to do about those things. So if you're involved or speaking to people about what type of steel or what type of concrete you might be using on a project, do check these out. They've been quite useful to a lot of the industry. And with that, I'm going to say thank you very much. I'm going to stop sharing my screen, and I'm happy to have questions. I think they're going to be relayed to me, but I'm happy to answer them for as long as we have left. Thank you.
Thank you so much, Will. That's very much appreciated. Obviously, that's a lot of information that you've passed across. So I've tried to capture all of the topics that you've mentioned and created links to send out post the talk. It'd be great if you could share the slides so that we could sort of make a sort of succinct single email that can go out for everyone that's registered. So if I start with Our first question is, in regard to a specific project from the looks of it, are you aware of Tribeca approach to carbon reduction by substituting much of the concrete blocks with compressed earth blocks? Structural engineering, a structural engineering point of view on this would be very interesting.
Yeah, I'm vaguely aware of it. In that so I am very much aware of this as a sort of an unbranded thing. So there are many others also trying to use earth blocks. I actually built a whole university out of earth blocks in Rwanda a few years ago as one of my last sort of built projects before I moved on to iStructE. So this is not sort of new technology in a way. I think what's really interesting is that yeah, we don't build many things out of earth in a country like the UK currently, and it's sort of seen as the realm of the niche one-off self-build homeowner who's got a plot of land out in a forest and wants to build something nice for themselves. And it really shouldn't be. And my understanding of what Tribeca have done is they've taken the spill from the excavation of a basement and actually used that material to then create their own bricks. Now, I might be wrong about that bit of the process, but that's the sort of thing that you can do with this. What's interesting is that in Germany, they're actually now codified the use of compressed earth blocks for brick making. So unfired bricks, in effect, are now in the codes in Germany. And these are the sorts of innovations that I think we should get really excited about and that we should be trying to sort of cultivate and do more with. Because if you can replace all of your internal concrete block walls with unfired earth walls, the carbon footprint of all those walls has been slashed probably by a factor of 10 or 20 compared to what they used to be. So yeah, really exciting stuff, things like that. And I'd encourage you to find ways to do more of that, use more of that in your projects, for sure.
One interesting point would be is obviously you mentioned towards the beginning of the talk that it's now being requested as part of CPD and sort of requirements for awards, etc., for engineers to think about sustainability, etc. Naturally, many of us will be working with structural engineers as part of our teams. Is there any sort of advice you'd give in regards to sort of how to sort of start that conversation? I presume it's obviously going to be a journey of development in regards to sort of how the modus operandi in regards to how we're working on projects currently to how we're going to be moving into sort of a new future. So is there any sort of advice you'd give in regards to sort of how to maybe set aside time or discuss this with the engineer to make sure that it's as fruitful as possible?
Yes, is the short. So the two words would be ask and early. So ask early. So what do I mean by that? Whenever I give training, whether it's to engineers or architects or somebody else, the thing that they always say holds them back the most from doing something more sustainable is whoever they consider to be their client, not wanting it, not asking for it, not being willing to pay for it. With the engineer, that's often the architect. With the architect, that's often the direct client, the person paying for the project, or maybe it's project manager. And so what I'd say, I use the word ask because actually if you are working with engineers, they may be waiting for you to ask them this stuff. And all you really need to do is say to them, what would be the embodied carbon footprint of this solution? And are there lower carbon versions we could think about too? I mean, we're quite used to saying to the engineer, well, what would be a cheaper way to do it? Or what would be a quicker way to do it? Or should this really be welded? Could we not bolt it? Would that not be quicker and cheaper? All we have to do is ask that question of what would be the lower carbon equivalent, and that gives them the opportunity to then say, okay, well, we can look into it. We think this, this, and this, and this. I also add the word early because I think that if you don't do that until you've already sort of finished your scheme, and you submitted something for planning, it's too late to do this with any form of cost efficiency whatsoever. You can switch out a material for a low carbon version of that material late in the day if you really want to, but that's probably going to cost you money. There's a green premium to a lot of these things. That the unfired bricks example might be a bit of an anomaly for that, where perhaps you can just change the brick walls out for earth bricks later on. But generally speaking, the earlier you have these conversations, the better. Mm-hmm. And the feedback I've had from people who have worked on, say, notifiable buildings in London, where they have to do whole life carbon reporting as part of planning, has been that as a result of that, when they're at concept stage, they're asking, well, what's going to be the carbon footprint and how do we keep it down? And when you're asking those questions at concept stage, Well, then you start to make decisions where you just come up with more material efficient, layouts for the building in the first place. Um, it's not to say that you've necessarily got to lose any of the architectural flair that you'd bring to the job at all, but you might end up in a position where you just make a really fundamental decision to not have a transfer structure above those ground floor shops and to just keep columns running through and work out how to make that work. Or to see if you can do 2 stories of basement instead of 4, or something like that. Those
Yeah.
concept level decisions, they usually save carbon and money at the same time. And
Mm.
you can just ask your engineers at that stage, well, you give us some options. Let us know what you know. So yeah, that would be the ask early. That would be the message there.
Great, thank you. I guess, yeah, it'll almost add in that procedure and process at the relevant time. That's a good point. So we had a question in from Steve in regards to the carbon tool, asking you may be aware of this. Field and Clegg Bradley have a carbon tool, and the question is how does this differ, the one from iStructE, from that, and also as a additional, is there a cross industry effort to align sort of almost like a standard calculator perhaps in part Z?
So I don't know a huge amount about Field and Clegg's tool. My Okay, so rather than trying to explain what I think theirs does, maybe I should tell you what I think might be different in ours. So our tool, basically, you tell it how much of each material you're going to use, and it's got default carbon factors for all those materials, and it adds up the total carbon footprint as results. It doesn't come prearranged with wall buildups or anything like that. At concept, if you were to use it at concept stage, you'd still need to do some estimates on how much concrete and steel and brick and glass and aluminium and so on you're going to use, and then you put those quantities in, it does the sums for you. There's like, to the second part of the question, there's not, I don't see there being a sort of appetite for industry trying to develop one tool to rule them all, as it were. And I think what's really interesting in this space is that you've got free tools like ours, like FCB's. You've got paid tools like OneClick, um, and you're only going to see more and more. And I think, if industry was to try and create one tool to do these things and hope to take over the market, I mean, that seems like a sort of weird way to go about building a monopoly. What would be better would just be that no matter, if we're in a position where no matter which tool you use, you always get the same answer. And so actually, I think the bigger challenge at the moment is for the people who make these different tools to work and collaborate with each other to check that we're all following the RICS guidance appropriately, because all these tools come back to the RICS professional standard. That carbon ecosystem slide very deliberately had the RICS standard right in the middle of it. And so I think the challenge is for the makers of these tools to check that they all interpret the RICS in the same way, so that we would get the same answer, assuming we've got the same scope and timescales and all that kind of thing.
Great. We've got a few more questions, so we've got a bit more time for some questions, which is great. We've got a question in from Damien. Naturally, the aim is to reduce carbon. However, we need to be mindful about the risks of it becoming too expensive and cost prohibitive for residential clients. So your thoughts on that would be great, really appreciated.
Yeah, I mean, like I was saying before, you can do cheaper and lower carbon at the same time. So if we take the example of a residential client who wants to, take an existing Victorian terrace and transform it into something new and modern, a really common decision will be to just take out the whole of the back wall, put in a steel transfer structure, a couple of pad foundations, a nice rigid one that doesn't sway side to side in the wind, so that you keep that stability system in there, and that will cost money. And you could often save money by leaving it a bit of a returns on the walls, so you only need a steel beam instead of a beam and columns. That beam is simply supported, so it's now thinner and lighter, and you maybe don't need to upgrade the foundations at all. And the downside is you've got slight returns, and you now need to do a bit of design to make sure that they look deliberate instead of accidental. But you've just saved carbon and money there. And there's loads of these examples out there. If you go on the Part Z website, there's a blog page on it, and we've got a blog post called "Low Cost for Low Carbon," something like that. And Simon Sturgis has pulled out his sort of top 10 favorite examples of this and chucked them all in with hyperlinks for you to look at. But it all comes back to talking about this from the beginning. If you wait until the design is too far progressed and then start asking how you could have saved carbon, it's too late to make these decisions. One resource I didn't mention actually when I was speaking, but I should have done, so I'll put a link in the chat now, is our hierarchy of net zero design. And on our hierarchy, we tell you that it all comes down to reducing material use first. Quickest way to do that is through reuse. Following that, it's then about structural configurations that are inherently low amounts of material. And then you get onto things like the nuances of utilization and waste and so on. And then you get onto material specification. And that stuff that's earlier on can be cheaper, lower carbon, quicker, lower risk, all of those sorts of things. So that's where we want the focus to be. And that's why it's ask early instead of just ask.
Great. We've got another question in from Snehal. I believe the question is in relation to, is there any courses that are provided that can help provide clarity in collaborating with engineers? I know there's some courses where there's short courses where you kind of have tidbits in sort of understanding, so there's a bit more understanding between one and the other. I can't I can't think of where those are off the top of my head, but I presume maybe on your website.
So I think we might have a course for non-structural engineers about structural engineers. I'd have to check, and I can send you a link afterwards if I can find it.
Yeah, that's almost. I think that's exactly the one that came to mind, to be honest.
And it's new and it came out this year, which is why I'm not 100% sure if that's the case. But that would be one example. The other example I'd give would be the net zero structural design course that we give. We've actually run that in-house for people a few times, and we've always, so when we run it as a public course, we say it's for structural engineers, and we've got the word structure in the title quite deliberately, and we get a cohort of structural engineers and they discuss design problems and so on. But we've run it for an architectural firm, and we've actually run it for, we've got a bunch of project managers from a local authority. We did it with them as well, and it worked beautifully for both groups. I think what was key was that it was the same sorts of people who were in that group. And so I think if there was appetite from a lot of people, maybe through this forum, who wanted to get together for something like that, we could look at running a version of that course where we would, have you all in there as architects on the architectural side rather than the structures side. And it would be all the same content, but we just approach it from that angle. And that again would bring in these questions of how do you do this stuff with the engineers rather than as the engineers. So that
that's great.
Way to approach it.
If possible, I'd greatly appreciate if you could send those two links across, and obviously I'll have a discussion on this side regards to the point you just made as well. Is there any other bits that you wanted to add whilst we're live with everyone? And just mindful of time. And honestly, thank you so much for this. A lot of information, a lot of reading for everyone to go away with. But I think a lot of really interesting points have been touched on. Hopefully, you've answered all relevant questions that everyone has. But please do, honestly, if you have any other questions, please do reach out. Naturally, I presume everyone is working on active projects with a range of engineers. Please do have discussions with them. From sounds of it, they have a lot of really, really good content to fall back on, and a great support from their institute as well. So a lot of really positives, a lot of positive things to take out from there. Regarding the next events that we have scheduled, is we have fastly approaching the end of the year. So we have 17th of September, we have limiting thermal bridging by design from Matthew Brook Peat. We have on the 15th of October, planning and regeneration update for this year from Sean Lewis and Garrett Jones of Savile Planning. On the 12th of November, we have wildlife-friendly lighting design from Jennifer Neal. And on the 10th of December, we have Why Specify Natural Slate and Phyolite from Simon Johnstone of SSQ Riverstone. Naturally, we're finalizing our 2026 calendar at the moment. I believe we are now booking Q3/Q4 from memory. So please do let me know if you want any other specific content to be added into the list. We're more than happy to accommodate. We are currently exploring options to have an additional talk for this year added in regards to the Building Safety Act, so please do keep an ear out for that. But thank you again to Will. Thank you for everyone attending, and I look forward to seeing you all next month.